Yeah, good day, friends. Welcome to Basic Electronics class. I'm Engineer Demola Emmanuel Tosin. Yeah, in our last class, we looked at Introduction to Electronics. We looked at the application of electronics, and then we looked at its functions. As part of the functions of electronic devices, we said an electronic devices can be used for rectification purposes, that is, for the conversion of alternating current into direct current. We also looked at amplification as part of the function of an electronic device. We said it can be used to raise the strength of a weak signal. We also looked at its function in terms of control. We said an electronic device can be used in regulating the voltage, maybe a voltage in a refrigerator or that of the speed of a car. We also said an electronic device can be used for generation, that is converting a direct current into alternating current. And I remember we said that the device responsible for doing that is for the conversion of a direct current into an alternating current, is called an oscillator. And as part of our class, we looked at atomic structure, the introductory part of it. We said an atom is made up of a nucleus and electrons. And we also said that nucleus consists of protons and neutrons. Also, we looked at the formula of atomic number, atomic weight, and so on. In this class, we will be looking at electron. Now, let me project my screen. We're looking at electrons. We know that in electronics, the essence why we study electronics is to study electrons, because electrons are the major particles that we study in electronics. Now, in our last class, we said that an electron is a negatively charged particle that have negligible mass. Now we need to look at some of its important factor or important properties. Now we need to look at some of its important properties. One of it is the value of charge of an electron, which is 1.6 times 10 to the minus 19 coulombs. We need to note all these things because all these properties and then values will be needed for our future calculation. The mass of an electron is 9.0 times 10 to the minus 31 kilogram, and then the radius of an electron is 1.9 times 10 to the minus 15 meter. Now, looking at those properties, we can conclude that the ratio of the charge of an electron to its mass is 1.77 times 10 to the 11 coulombs per kilogram. And this means that when we compare the mass of an electron to its charge, we know that the mass of an electron is very, very small. That is, an electron is very, very light in terms of its mass, so which makes it very, very mobile. That is, an electron can move around an outer shell or around an orbit, which is one of the important property of an electron. It has a very light mass. Now, in electronics, or let me just say basic electronics, because in this class we won't be going so deep, but we'll be covering almost every part of electronics. So for those in electrical electronics, when you get to your year 2, you can then move to the advanced parts. And those in computer science and computer engineering, you will be applying semiconductors a lot, even as you go on in your course. When you get to another level, you'll be doing what we call computer architecture, whereby you'll be studying and then We'll be studying how motherboards are being made. We'll be studying different components on the motherboard, which can also be traced back to semiconductors. Now, we've looked at some important properties of an electron: the charge, the mass, and radius. Now, the next thing we need to talk about is the energy of an electron. An electron moving around the nucleus possesses two types of energy: the kinetic energy due to its motion, and then the potential energy due to change on the nucleus. The total energy of an electron is the sum of these two energies. Now, the energy of an electron increases as its distance from the nucleus increases. Now, this is what we are saying. In our last class, we looked at structure of elements, and we looked at the formula for deriving or calculating the number of electrons that can be in a particular orbit, and that's 2n squared. The energy of an electron increases as its distance from the nucleus increases. That is, the higher the number of orbits of an atom, the higher the energy of the electrons in the outermost part of the orbit. Which means, now, in electronics, what we deal with so much is the last electrons in the last orbit, or let me say electrons in the last orbit. Those are the free electrons that are free to move around or to leave the orbit to pair with another electrons when the potential differences are applied across the atom. Now, if you look at this place now, it's saying this last orbit electrons plays an important role in determining the physical and chemical properties of the material. Now, looking at this diagram here, you see that we have about 6 orbits here. 1, 2, 3, 4, 5, 6. We have 1 electrons here. We have another one in the second orbit. We have another one in the third, fourth, fifth, and sixth. Now, the electron here in the last orbit has the highest energy, because we said the energy of an electron, from here we said the energy of an electron increases as its distance from the nucleus increases. So which means this is the nucleus here, right? Now, we said the energy of an electron increases as its distance from the nucleus increases. So which means, like this in this diagram here, the electron in the second orbit has more energy than the electron in the first orbit. The electron in the third orbit has more energy than the electron in the second orbit, and so on and so forth. We're just trying to study the energy of an electron, which means electrons in the last orbit of any atom possesses the highest energy of that atom. Are you with me? Now let's now move on to what we call the valence electrons. Now, we've said in our previous class, we looked at structure of an element, and then we looked at some element of I think we looked at sodium and magnesium. That's correct. And then while studying them, we see that the outermost part or the outermost orbit of any atom can have a maximum of 8 electrons, cannot have more than 8 electrons. Now, the electrons in that outermost part are called valence electrons. They are called valence electrons. Yeah, the electrons in the outermost part of an atom are called valence electrons. And we said the valence electrons of any atom cannot be more than 8. Now, these valence electrons determine the physical and chemical properties of a material. These electrons determine whether or not the material is chemically active, metal or non-metal, gas or solid. This is what we are saying, that is, the valence electrons of an atom can enable us to determine if the atom is a metal or a non-metal, or is a gas, or is a solid. You understand that as we move on in the course. Now, on the basis of electrical conductivity from our previous physics and interscience, We know that materials are generally classified into three. That is conductors, insulators, and semiconductors. From our secondary school physics, we know that conductors are material that allow the passage of electric current through them. Insulators did not allow the passage of electric current. Semiconductors, they act as both conductor and insulator. Now, from what we said valence electrons can enable us to determine the physical and chemical properties of any atom. We can use valence electron to determine whether a atom is a conductor or an insulator or a semiconductor. So now we can say from my slide here, that is rule number 1 that we can use to determine whether an atom is a conductor or an insulator or a semiconductor based on the valence electron. Rule number one says, let me get my pointer here. Rule number 1 says, when the number of valence electrons of an atom is less than 4, the material is usually a metal. Now, this is a rough rule, and we are not saying it is all applicable to all atoms, but some extent we can always apply this rule to determine whether a material is a conductor or an insulator or a semiconductor. We said when the number of valence electrons, that is the number of electrons in the outermost shell of that atom, is less than 4, the materials are usually a conductor. For example, when we look at sodium has just 1 electron in its outermost shell. Now that is less than 4, so we can say sodium is a metal, that is a conductor. Now when you look at magnesium too has just 2 electrons in its outermost shell, so we can say magnesium is a metal, that is a conductor. Same thing applicable to aluminum, which has 3 electrons in its outermost shell, or we can say 3 valence electrons. So we can say these 3 atoms here, 3 elements that we use for scenario here are metal or conductors. So with this simple rule, we can use our valence electron to determine the property of an atom. Now let's look at the second rule. When the number of valence electrons of an atom is more than 4, that's the second rule. When the number of valence electrons of an atom is more than 4, the material is usually non-metal or an insulator. When it is more than 4, it is usually a non-metal or an insulator. For example, here we looked at nitrogen, sulphur, and neon. Now, nitrogen has 5 electrons in its outermost shell. 5 electrons in its outermost shell. Sulphur has about 6 electrons in its outermost shell, and neon has about 8 electrons in its outermost shell. So if you look at all these atoms that we have here, they are more than 4. So with that simple rule, we can say that this atom or this element here, they are a non-metal or an insulator. So any atom that has more than 4 electrons or more than 4 valence electrons, we can say they are what? They are non-metal or an insulator. Now let's move on to number 3. When the number of electrons, or when the number of valence electrons, or when the number of electrons in the outermost shell of an atom is 4, exactly 4, the material has both metal and non-metal property. That is, the material is a semiconductor. And a common example, we have silicon and the germanium. Now for silicon has 1, 2, 3, 4 electrons in its outermost shell, or we can say 4 valence electrons. Germanium too has 4 valence electrons, and the same thing as carbon. So these 3 elements here, these 3 atoms here, are what? Are semiconductors. So with this simple rule, though I call it a rough rule, we can use the valence electrons, that is the electrons in the outermost orbit of an atom, to determine its physical and chemical properties. So with these three rules we looked at, we said when the first one, when the number of electrons is less than 4, the material is a metal or a conductor. When it is more than 4, it is an insulator. And when it is exactly for the material, is a semiconductor. Now that's valence electrons. Like again, valence electrons are the electrons in the outermost orbit of an atom. Now let's move on to what we call free electrons. Now the valence electrons of different material possess different energies. Like it was illustrated when we look at energies of an atom. We said when electrons in different orbits of an atom possess different energies. Electrons in the second orbit has more energy than electron in the first orbit, and so on and so forth. Now, valence electrons of different material possess different energy. The greater the energy of a valence electron, the less it is bound to the nucleus. Now, which means when the energy of a valence electron is more, it simply means that electron is so far from the nucleus. Like it was illustrated before. We said the higher the orbit, the higher the energy of the valence electrons, or of the electrons in the outermost shell of an orbit. So now, for example, when we say we have an atom with about 3 orbits. Please don't mind my diagram. I don't have a pen here to annotate. I'm just trying to manage my mouse. When we have an atom with about 3 orbits, now, and we know that the electron here, which is the valence electrons, has the higher energy compared to electrons in the second orbit and in the first orbit. Now, we know that this electron is a valence electrons, right? Valence electrons, right? Now, so when electrons are so far from the nucleus here, this is the nucleus. When electrons are so far away from the nucleus, or are loosely attached to the nucleus, these electrons move at random within the materials and are called free electrons. Valence electrons, like I said, they are electrons in the outermost shell. But when we now have electrons that has a lot of orbits, in such a way that the valence electron, the electrons in the outermost shell, is so far from the central nucleus here, those electrons are called free electrons because they are loosely attached to the nucleus. And then when you have such scenario, when you have electrons that are so far from the nucleus, then they have the capability to move at random within the material. That's why they are called free electrons. They are free to move at random within the material because they are not attached. They are so far away from the nucleus, which give them the ability to move freely within the material. So the difference between valence electrons and free electrons. Now, valence electrons are electrons in the outermost shell of an atom. For example, an atom that has just 2 orbits. The valence electron is the electrons in the last orbit. For example, now let me draw this. We have an atom here that has just 2 orbits, right? This electrons here is the valence electron. Now, this one that has 3 orbits, the last electron here is the valence electron, right? Now, well, we have a scenario whereby we have so many orbits. Like, let's say we have 4 orbits here. The last electron is also called a valence electron. This is also called a valence electron. But that atom that has 4 orbits, the last electron, which is in the 4th orbit, is so far from the nucleus, so far from the central nucleus here, and gives that electron the flexibility to move freely at random within the material. That is why it is called free electron. So any atom that has a lot of orbits, that has more orbits, for example 4, 5, 6 orbits, and then the last electron maybe in the 6th or 7th orbit, which is so far away from the nucleus, those electrons in that last orbit are called free electrons. Let me simply put, any electrons in the orbit of an atom that is so far from the nucleus of that atom, those electrons are called free electrons. Now, there will be room for question and answer in our Zoom class, and that will be at the mid of this month. We'll be hosting a Zoom class, so you can all gather your question to ask your question, and I will be available to respond to you. By that, during that period, we'll be using maybe a marker board that I will have to use a camera stand, so you can always see my marker board, or I get a new stylus pen which I've ordered for, it's here to arrive, so I can use to annotate while teaching instead of using my mouse. So, but for now, let's just manage the resources we have now. Now, this is what I'm saying. If you look at this behavior of free electrons, now we said free electrons are electrons that are loosely attached or that are far away from the nucleus. Now, when there are no current flow, if you see this, let me get my 2. When there are no current flow, you see all these electrons, you see they are moving at random within the atom, moving at random within the atom. Now, the electrons, the free electrons. Now, but when potential difference is applied across this atom, the electrons are now moving towards the positive terminal of the potential difference applied to this atom. You see the electrons now are now moving, they are now moving, which make them to conduct electricity. Free electrons can be easily removed or detached by applying a small amount of external energy. As a matter of fact, these are free electrons which determine the electrical conductivity of a material. On this basis, conductors, insulators, and semiconductors are defined as under the following rule. We'll look at it. This is what we are trying to say here, that is free electrons can be removed or detached from an atom by applying a small amount of energy. If you look at here, you see these electrons here are detached from the atom, and then they are moving away from the atom. They are moving away from the atom here, as you can see from this scenario here. But when there were no current applied to the atom, you see electrons are moving randomly within the material. But when electrical energy is applied to the atom, you see now the electrons are moving away, leaving the atom, which makes the material to conduct electricity. Now, on the basis of conductor, insulator, and semiconductor, we can define them on this basis of free electrons. Now, number 1, a conductor is a substance which has a large number of free electrons. When potential difference is applied across a conductor, the free electrons move toward the positive terminal of supply, constituting electric current, just like what we have here. Now, number 2, an insulator is a substance which has practically no free electrons at ordinary temperature. Therefore, an insulator does not conduct current under the influence of potential difference. That is, an insulator doesn't have any free electrons. Now, a semiconductor is a substance which has a very few free electrons at room temperature. So, which makes them, by default, under the influence of potential difference, a semiconductor practically conducts no current. So now, if you look at what we have just looked at in this class, we looked at electrons and some of its property. We looked at the energy, telling us that electrons with or atom with larger amount of orbits. The electrons in the last orbit of that atom possesses more energy than every other electrons in that atom. The higher the orbit, the higher the energy of the electron of each orbit. Now, we looked at valence electrons, which means electron in the outermost part of an orbit. And we said an outermost part of an orbit cannot have more than 8 electrons. We looked at how we can use valence electrons to determine whether a material is a conductor, an insulator, or a semiconductor. And we looked at the free electrons, which is telling us valence electrons that are so far away from the nucleus. And we looked at how we can use that basis to define a conductor, insulator, and a semiconductor. We have to stop here for today, and in our next class, which I'll be dropping very soon, we'll be looking at energies band theory in solid. We're looking at energy band theory in solid. Under that, we'll be looking at valence band, the conduction band, and the forbidden band or forbidden gap. And from there, we will move on to semiconductors. So before then, I want us to write all our questions down. This is just the introductory part of this course. Write your question down somewhere, and then during our Zoom meeting, you ask all your question. Now, let me let you know this. All materials will be available on the HLMS for free. Nobody is collecting money from you for any soft copy as far as my course is concerned. Initially, we wanted to do that maybe because students are finding difficult to get the hard copy. But anyway, just try your best to get the hard copy. You can contact the HOC of Electrical Electronics. He's going to tell you how you can get the hard copy. So, but all soft copy, this PowerPoint will also be uploaded to the HLMS after this class, and then you can always download to read. And all PDF file that I'll be sending to you, I'll be uploading to the HLMS. You can download them to read. So, till then, stay safe and try your best to read your books.